YouTube channel. In today's lesson, we are going to be looking at a very interesting topic because it is a compulsory topic for every student preparing for JAM exam or XSC exam. Now, what is that topic that we are going to discuss today? We are going to be discussing a topic called radioactivity. Now, what is the meaning of the word radioactivity? What does radioactivity mean? Radioactivity, from the definition, is the spontaneous emission of radiation from the nucleus of a radioactive element. Okay, e.g., an example of a radioactive element is your uranium, which has a symbol U, or let's talk about polonium, which is PO. So a radioactive substance are those substances that spontaneously emit radiations. Okay, radioactivity was first observed by a scientist called Henry Becquerel. Yeah, Henry Becquerel was the first scientist to observe radioactivity in the year 1896. Then later it was modified by two scientists called Perry and Marie Curie in the year 1898. So you must understand that radioactivity was first observed by Henry Becquerel in the year 1896. Now, the first radioactive element to be discovered, according to Henry Becquerel, was uranium. So radioactivity was first observed in uranium in the year 1896. And Henry Becquerel discovered that a sample of uranium crystal could spontaneously emit radiation. So he discovered that uranium and all the compound of uranium was exhibiting this same emission. So therefore, he called it radioactivity. Now, what is this radiation that we are talking about? If I have a radioactive substance, let's look at something here. Now, if we have a radioactive substance, I've told you before that an example of a radioactive element is uranium, polonium, and the rest. Okay, now let's assume we have the nucleus of radioactive substance. This is the nucleus. Now, the nucleus usually emits radiations. Okay, the particles that are emitted from the nucleus of a radioactive substance is what we call radiations. Now, this radiation is of two types. We have the major radiation and we have the minor radiation. Now, we have major radiations and we have minor radiations. Your major radiations are of three. What are they? One is called alpha. Alpha has a symbol like this, or you write your helium atom. This is your alpha. Another radiation, major radiation, is your beta. Okay? Beta is also called negatrons. And this beta has a symbol which is like this, or you write it this way. This is your beta, so it must be noted. So when we talk about radiations of radioactive elements, we have the major radiation, which is alpha. We have another one called beta or negatron. Then thirdly, we have what we call gamma radiations. It must be noted. Your gamma radiation has a symbol like this. Don't forget that gamma radiation is an electromagnetic wave and it is also a radioactive wave. So you must understand that this gamma has a dual nature. It must be noted. So radiations from the nucleus of radioactive substance are of two types. We have the major radiation, which include your alpha, your beta or negatrons, and your what? Your gamma. Then when we talk about the minor radiation is also called subatomic radiation. It's also called what? Subatomic radiations. is also called subatomic radiation, meaning they are the constituents of an atom. And what are these subatomic radiation? Let's look at it carefully. For subatomic radiations, which is also called your minor radiation, we have number one, we have the proton. Yes, we have the proton. Is proton a radiation? Yes, it's among the minor radiations. Okay, we have proton, which has a symbol like this. We have neutron, which has a symbol like this. Then we have positron. Your positron is also called positive electron. Positive electron. And this your positive electron has a symbol like this. So it is the direct opposite of your beta, which is negatron. The difference between your positron and your negatron is that your positron has a positive charge. It is called positive electron, while your beta has a negative charge. Look at it, and it's called negative electron. So understand the fact that number one, radioactivity was first observed by Rebecca in the year 1896, and it was later modified by two scientists, which were a couple called Perry and Marie Curie. Okay, so understand the fact that from the nucleus of radioactive substance, we have what we call radiations, and these radiations could be major or minor. Minor radiations are also called subatomic radiations. What are your major radiations? You have alpha, which has this symbol and this symbol. You have beta, which has this symbol or this symbol. Then we have gamma. Okay, these are the three major radiations. Then for minor radiations that are emitted from the nucleus of radioactive substance, we have proton. Yes, protons are sometimes emitted from the nucleus of radioactive substance. We have neutron, which has this symbol. Then we now have positron. Positron is also called a positive electron. Okay, yeah, it's called a positive electron. It has this symbol, while your beta has this symbol. So understand the fact that this alpha radiation is positively charged. Yes, the alpha particles is positively charged. It must be noted. Your beta particles is negatively charged. Take note of that. Alpha is positively charged, beta is negatively charged, while your gamma is neutral. It has no charge. It is what? Neutral. Take note of that. Alpha is positive, beta is negative, gamma is what? Neutral. Now let's talk about the minor radiation or the subatomic radiation. Your proton, don't forget, it is positively charged. Your neutron, it is what? Neutral. It has no charge. While your positron is positively charged. It must be noted. Now let's take a look at what happens to this radiation when it is placed in a magnetic field or an electric field. Let's do that quickly. Now let us look at the behavior of your alpha, beta, and gamma in an electrostatic field or a magnetic field. Don't forget that your beta particles is negatively charged. So because the beta particle is negatively charged, it will be deflected to the positive pole in an electrostatic field. Why? Positive attracts what? Negative. Now, the radiation that is deflected to the negative pole must be positively charged. And that particle is your alpha particle. Please take note of these symbols, okay? Then when you look at this guy, you discover that this one is not deflected to the positive, neither is it deflected to the negative. Simply because gamma ray is neutral. It does not have a charge. So because it does not have a charge, it will not be deflected to the positive pole nor the negative pole. And that's why it's going straight. But when you look at it carefully, you discover that it is partially or slightly deflected. That's what we can say about the gamma ray. Now the reason why it is partially or slightly deflected is because it is part of the radioactive ray. Okay, and another reason you must understand is that your gamma ray is highly massive. What does that mean? It is too heavy to be deflected towards the negative pole, not to the positive pole. So that is why it does not have charge and is highly massive. So for that reason, it is neither deflected to the positive pole nor the negative pole. Now, you must understand something here, that you have a lead block here. Why? Because radioactive material are best stored in a block lined with lead. Okay, so the best material for storing radioactive substance is your lead block. So you have a lead block here and you have the radioactive substance here. Now the radiation comes and becomes deflected on the what? Electrostatic field. Now let's look at the behavior in a magnetic field. The same lead block that we have here, look at the beta particle. It is deflected towards the north pole, while your alpha particle is deflected towards the word south pole. Then you discover that the gamma rays neither deflected towards the north pole nor the word south pole. So this must be what? Taken under what? Consideration. Let's look at this quickly. Let's look at the characteristics of radiation. We are going to begin with the characteristics of alpha radiation. Alpha radiation. Let's look at the characteristics of each of them carefully. Number one, you must understand that alpha particles, it is helium atom in nature. That's number one. It must be noted. Now, it is helium atom in nature. For that reason, if you look at the symbol for helium, you have 4 here, you have 2 here, and helium is like this. So we could say that number 2 characteristics, it has a mass number of 4 and an atomic number of 2. It must be noted. So take note of this. It has a mass number of 4 here and an atomic number of what? 2. That's why, because it is helium atom in what? In nature. Don't forget that the symbol for alpha particles is this symbol, or you can simply use this. Number 3 characteristic about alpha particles is that it is deflected to the negative pole in an electrostatic field, or deflected towards the south pole in a magnetic field. So we can say that it is deflected to the negative pole. Why is it deflected to the negative pole? Because the alpha particles is positively charged. Yes, it is deflected to the negative pole or the south pole, or the south pole. Now, why does it go to the negative? Because alpha particles is positively charged. Number 4 characteristics about the alpha particles is this, is that it's the alpha particles, when being emitted from a radioactive source, the mass number of the radioactive substance is reduced by 4, while the atomic number is reduced by 2. What do I mean? Look at this. If I have an atom like this, I have an atom that has a mass number A and an atomic number Z. Now, if this guy is a radioactive substance, if this guy is a radioactive substance and it emits alpha particles, this is what will happen. The radioactive substance will be transformed into another substance. Why? Another substance. Why? The mass number of that particle will reduce by what? By 4, because it has emitted alpha. So we are going to have A minus 4. While the atomic number will reduce by 2. As you can see here, it has 2 here. So we have Z minus 2. Then you have plus your alpha weighting particle. It must be noted. So whenever an alpha particle is emitted from a radioactive substance, you remove 4 from the mass number and remove what? 2 from the atomic number. Let's take a look at this example, please. If I have uranium 238 92 like this, and it emits alpha particles, What do you think will happen? We are going to remove 4 from here to give us 234 and remove 2 here to give us what? 90 to form a new substance. That new substance is called thorium. Yes, it's called what? Thorium plus your alpha particles to balance the equation. So whenever a ready substance such as uranium emits alpha particles, you remove 4 from here, remove 2 from here to form 234. Instead of 90, you now have what? 90. If you watch very well, when you add the mass number of the new substance plus the mass number of the alpha particle, which is 4, you have the same mass number of the initial radioactive substance. When you add the atomic number here to this one here, add the atomic number here to this one here, you have what? 92. That gives you the same substance. So the sum of the masses in the left hand side must be equal to the sum of the masses in the right hand side. So when a particle emits alpha, you remove 4 from the mass number and remove 2 from the atomic number. Another important characteristics of alpha particles is that it has the least penetrating power. Write it down. Take your pen and your book, write it down. It has the least penetrating power. It has the least penetrating power. It has the least penetrating what? Power. What does that mean? It can only pass through few centimeters in air and can be absorbed. When alpha particle is in air, it can be stopped or absorbed by a thin paper or a tissue paper. So it must be noted that it can be absorbed by a tissue paper. A tissue paper or a thin paper. Why can alpha particles be absorbed? Simply because it has a very low penetrating power. So we said it has the least penetrating power. Another interesting characteristics of the alpha particles is that it has the greatest ionizing power. Okay? It has the greatest ionizing power. It must be noted. It has the greatest ionizing power. It has the greatest ionizing power. Yes, it has the greatest ionizing ability of all radiation. Finally, you must note this. It can be detected. It can be detected. It can be detected with what? With zinc sulfide. Please note this. It must be noted. Alpha particles can be detected with what? Zinc sulfide. So take note of the characteristics of what? Alpha particles. Let's go to beta particles quickly. Characteristics of beta particles. Number 1 characteristic of beta particles is that it is electrons in nature. It is electron in nature. We call it electron or we call it negative electrons. And negative electrons are called negatrons. So it has the symbol like this. -1. Here is what? 0. It is electron in nature. Number 2. It is negatively charged. It is negatively weighting charged. Okay? Now, because this guy is negatively charged, it will be deflected towards the positive pole or the north pole of an electric field or magnetic field. So take note of that. It is deflected towards the positive pole or the north pole of a magnetic field. Yes, this is what we have. Then number 4, please, I want you to note this, that when a radioactive substance emits beta particles, the mass number of that substance remains the same, but the atomic number will increase by 1. It's not going to reduce, no, because beta is negative, that's -1. So the atomic number will increase by 1, okay? When a radioactive substance emits beta particles, beta particles, the word, the atomic number will increase by 1. Will increase by 1. It must be noted. I'll give you an illustration. If I have an atom like thorium 230 90, okay, let's assume we have this thorium, or you can put 234. Now if I have thorium and this thorium emits beta, it will form a new substance. What is the new substance? First of all, the mass number of the new substance remain the same, so we are still going to have 234. But what will happen to the atomic number? Because say na beta, it will increase by 1, so you have 91. This substance is called protactinium. Okay, it must be noted. Then you have your word, your electron, which is your word, your beta. So if you watch very well, 234 plus 0 will still give us 234. 91 minus 1 will give us waiting 90. So it should be noted that when a radioactive substance emits a beta particle, you must note that the atomic number of the new substance will increase by 1, while the mass number will do what? Will remain the same. It must be noted. Now, other characteristics about your what? Your beta particles is this. You must understand that it has a moderate penetrating power. What do I mean by that? Penetrating power. Now, the penetrating power of beta is higher than that of alpha. Don't forget that alpha can be stored by a tissue paper, but beta can pass through tissue paper but can be absorbed by what? By a metal foil, e.g. aluminum foil. So it has a greater penetrating power than that of your alpha. It should be noted. So it can be absorbed by a metal foil or metal sheet, metal foil, e.g. aluminum foil. So you watch very well that your beta particle has a greater penetrating power than your what? Your alpha. More also, please take note of this. It can be detected, it can be detected by, what do we use to detect beta particles? Take note of this. You can use anthracene to detect it. So the chemical compound used for detecting beta is anthracene, while the chemical compound for detecting alpha is your zinc sulfide. It must be noted. Now let's quickly go over to what we call gamma particles. Now, gamma ray, for gamma ray, let's look at the characteristics. Number 1, it is a radiation and a wave. Don't forget that gamma ray is one of the electromagnetic waves. So it's a radioactive radiation and it's also a wave. It must be noted. Number 2, it has no charge. It has no charge. It does not have charge. Number 3, cannot be deflected to the negative or positive pole, deflected by electric and magnetic field. Cannot be deflected by electric and magnetic field. Please take note of that. It has the greatest penetrating power. Greatest penetrating power. It has the greatest penetrating power. So that is, it can pass through a tissue paper or a tin paper that stops alpha. It can pass through metal foil that stops beta, but can only be absorbed by a dense lead or iron block. So take note of that. It can be absorbed or stopped by a dense lead or iron block. So take note of that. So it has the greatest penetrating power. its speed is 3 times 10 raised to the power of 8 meters per second in air or vacuum. So that means your gamma ray has the same speed as the speed of light because it is one of the electromagnetic wave. Now, what do we use to detect gamma ray? It can be detected by 1. Sodium thallium iodide. And zinc sulfide. These are the 2 substances used to detect for what? Gamma ray. So these are the characteristics of gamma, alpha, and beta. Finally, we'll look at a diagrammatical illustration to review the penetrating power of alpha, beta, and gamma. Let's do that quickly. Now let's look at their penetrating power. Look at your lead block, and this is a radioactive substance. Now emitting 3 of these radiations. Now the radiation that can be stored by a tin or tissue paper, that particular radiation that cannot pass through this tin paper is called alpha. Take note of that. So alpha is absorbed by a tissue paper. Note that. Now there's another radiation that is stronger than alpha that was able to pass this tin or tissue paper but became absorbed by a metal foil, e.g. aluminium foil, okay? Or you can simply say a metal sheet. That radiation is called beta. Take note of that. Beta has a greater penetrating power that can pass through tissue paper but absorbed by a metal sheet. Finally, we have the what? The third one that passes through thin paper, that passes through a what? A metal sheet, but is being absorbed by a what? A lead block. It has the greatest power. It is known as your word, gamma ray. Okay? Don't forget their symbol. Don't forget that this guy is what? Neutral. Don't forget that this guy is what? Negative. And don't forget that alpha is what? Positive. Take note of that. Don't forget that alpha goes to the negative pole, beta goes to the positive pole, gamma is not deflected because it is neutral and highly what? Massive. Now, if a particle emits gamma, the mass number and the atomic number will remain the same, irrespective of the number of gamma. Meaning, say, if I get 234.92 uranium and it emits gamma, the substance form will still be uranium, 234.92 uranium plus your gamma particle. So when a radioactive substance emits gamma, the mass number and the atomic number remain the same. For alpha, you remove 4 from the atomic mass number and 2 from the atomic number. While for beta, you discover that the atomic number will increase by 1, but the mass number remains the same. So finally, we have come to the end of radioactivity part 1. We hope to continue from here in our subsequent lesson. If today na the first time we dey come across my YouTube channel and you dey prepare for JAMB or XSC exam, please do well to subscribe. Also on your notification bell so that whenever we come online again to get across to you. Thank you very much. I'll see you in my next video.